Okay, this is 4.1.2 airplane efficiency. I am doing my presentation on the Airbus A318, and we have a couple of pictures here on the front cover. It's a very compact, much smaller passenger aircraft. So moving on to the history of the Airbus A318. This aircraft began as a smaller version of the Airbus A320 with seating for around 100 people. Began as a collaboration among Chinese, Singaporean, and European manufacturers as they looked for a more compact and efficient version of the A320. During the design process of the A318, they encountered a lot of problems, which firstly being the decline in demand for new aircraft following the September 11 attacks. It's very clear why people were not flying and looking for new aircraft after these attacks. And another reason was the new Pratt& Whitney turbofan engines, which burned more fuel than expected. And by the time CFM International had a more efficient ready for market, many A318 customers had already backed out. Most A318 aircraft retired from airline service because their engine components had become more valuable than the whole aircraft, which is very unfortunate. Moving on to the flight speed and flight options. The typical cruising speed for a long distance commercial passenger aircraft is approximately 880 to 926 kilometers per hour. An aircraft is designed to deliver the best compromise of speed, fuel economy, load capacity, and a couple of other parameters. The cruising speed is the speed at which the design optimizes the combination of all of these parameters. So the speed at which an airplane travels is basically to avoid exceeding an average cruising speed where the distribution of forces on the wings and airflows will become so great that the airplane will become uncontrollable. So if you're traveling too fast and the lift or the downforce becomes too great, the aircraft could fall into a dive or an uncontrollable fall. And that would be a horrible thing to happen to a passenger aircraft where people could get hurt. Moving on, here is the spreadsheet and data calculations that I made about the fuel consumption, fuel cost, and a couple of other factors that go into it. Here you can see all of the different values in gallons per hour, dollars, years, kilometers, and then flights. Even now today, there are still quite a few Airbus A318s going out, mostly in France, where they still have a lot of them working. In the bottom area, you can see the percent amount reduced from fuel cost, and then the new fuel cost and cost of lifespan. These are obviously pretty high numbers, but as we move on, we can see the graphs here where every time you reduce the fuel consumption is going to go down and the cost of lifespan is going to go down with a pretty linear trend. Moving on to some fun facts. The Airbus A318 is the largest commercial aircraft certified by EASA for steep approach operations, which means that it can actually make flights into London Airport where this is necessary. The Airbus A318 became available with sharklets or wingtip devices which reduce lift, drag, and improve efficiency through reduced fuel consumption. And I put a little picture on the side here to see just how those sharklets work and reduce the lift, or I'm sorry, drag. The Airbus A318 actually had 0 accidents as of 2020, so it's a pretty major feat, even though there is quite a few reduced number of aircraft that are in operation. But overall, a pretty strong aircraft that is still flying out there, and that's about it. Pretty neat stuff. Thank you.